Good morning. Today we will see what is Poyntings theorem. Poyntings theorem is named after the physicist John H. Poynting, and we all know that energy is transmitted from transmitter to receiver by means of electromagnetic wave in free space. Power flow in any medium can be obtained by using Poynting theorem, and this theorem was developed in 1884 by the English physicist John H. Poynting, and this theorem is named after the same physicist. And the theorem mainly explains the law of conservation of energy, and this can be obtained using the relations from Maxwell's equations. We are having 4 Maxwell's equations. We use this Maxwell's equation to obtain the relation of Poynting theorem. So coming to the derivation part, from the Maxwell's equation or the curl equation of Maxwell, we have del cross H is equal to J plus dou D divided by dou T. Let this be the equation number 1. That is the first Maxwell's equation. Del cross H is equal to J plus dou D divided by dou T. Now consider the scalar product with E. You are going to consider the scalar product with the electric field intensity E. So while considering the scalar product, it is E dot del cross H is equal to, on the right hand side also you are multiplying this, so E dot J plus E dot dou D divided by dou T. Let this be the equation number 2. Again, here we have to consider the different identities also, so we will go to the first identity now. Vector identity. Del dot E cross H is equal to H dot del cross E minus E dot del cross H. This is a standard identity. So from this I can obtain the relation for E dot del cross H. Here also we have E dot del cross H. So we are obtaining the relation from this vector identity, that is E dot del cross H is equal to H dot del cross E minus del E cross H. Let this be the equation number 3. That is, you are taking this on the right hand side. So E dot del cross H is equal to H dot del cross E minus del dot E cross H. That is equation number 3. Now we can equate the equations 2 and 3. That is equating 2 and 3. We are having this equation as equation 2 and this is 3. So equating 2 and 3, we have H dot del cross E minus del dot E cross H is equal to E dot J plus E dot dou D divided by dou T. Let this be the equation number 4. But we have again H dot del cross E. See, this del cross E is known as minus dou B divided by dou T. Already we have studied from Maxwell's equation. So from this we have minus del dot E cross H is equal to E dot J plus E dot dou D divided by dou T plus this term is taken on the right hand side, H dot dou B divided by dou T. Let this be the equation number 5. That is, you are considering minus del dot E cross H is equal to this term minus H dot del cross E. H dot del cross E is equal to H dot minus dou B divided by dou T. So now we will expand this. Minus del dot E cross H is equal to E dot J plus E dot dou D divided by dou T plus H dot dou B divided by dou T. That was equation number 5. Now we will give certain specific terms for this E dot dou D divided by dou T and E dot dou B divided H dot dou B divided by dou T. That is, E dot dou D divided by dou T can be written as E into dou by dou T of epsilon E, that is B is equal to epsilon E. That is the second term. No. So E dot dou D divided by dou T is equal to E dot dou by dou T of epsilon E, which can be written as half into dou by dou T of epsilon E square. Half into dou by dou T of epsilon E square. See, you can so half into dou by dou T of epsilon E square, when expanded, this will be equal to epsilon taken outside, since it's a constant, epsilon by 2 into 2 E into dou E divided by dou T. So this get cancelled. That is equal to the same equation, E into dou by dou T of epsilon into E. That is what you obtain here. So this value of E into dou D divided by dou T can be substituted as this term. Okay, so I am substituting it here. Similarly, the value of H into dou B divided by dou T can be written as H into dou by dou T of B is equal to mu into H, right? So mu into H, so it can be written as half into dou by dou T of mu H square. Okay, so the next fifth expression can be rewritten as minus del dot E cross H is equal to E dot J plus this term plus the H dot dou B by dou T can be replaced with this term. Now again, the value E dot J, the first term is E dot J. E dot J is equal to E into sigma E. Sigma is a conductivity, which is equal to sigma E square. Okay, so we can substitute all those terms on the right hand side. You got the first term, second term and the third term. So we'll rewrite the fifth equation as, therefore the fifth equation can be written as minus del dot E cross H is equal to sigma E square plus dou by dou T of half into epsilon E square plus half into mu H square. Okay, so that is the sixth equation. Minus del dot E cross H is equal to sigma E square plus dou by dou T of half epsilon E square plus half mu H square. That is the sixth equation. Now taking volume integral on the right hand side and the left hand side, we are going to consider volume integral here. That is minus integral over V, the same equation, del dot E cross H dV is equal to the volume integral of sigma E square dV plus integral over V half into dou by dou T of epsilon E square dV plus integral over V half into dou by dou T of mu H square dV. Let this be the equation number 7. So we have considered the volume integral. That is, you can write it here, that is considering the volume integral on LHS and RHS. You are obtaining this equation. The next step is applying Gauss divergence theorem. Gauss divergence theorem convert the volume integral to surface integral, or the surface integral to volume integral. So I'm going to convert this left hand side to surface integral. So del dot, it converts this dot product also, that is minus integral over V. Del dot E cross H can be written as in the form of surface integral, that is minus surface integral over S E cross H ds is equal to the same thing on the right hand side, that is sigma E square dV plus half into dou by dou T of epsilon E square dV plus half into dou by dou T of mu H square. Now we'll see what can you analyze or what can you interpret from this final equation of Poyntings theorem. The left hand side of Poyntings theorem says that the surface integral of E cross H ds. The surface integral of E cross H ds can be represented as, that is the first part, it is represented as capital S or P. In some textbooks you are given as capital S, and the other textbooks it is given as capital P. You can give any expression for this E cross H. E cross H is equal to P or S. So this shows the power flow or power flowing out of the surface. You will see the first term on the right hand side. The first term shows that it is integral over V sigma E square dV, that is the heat loss due to resistance, or it is known as the ohmic loss. It shows the heat loss due to resistance, or it is the ohmic loss. The next term or the second term on the right hand side, that is dou by dou T of epsilon E square. So it is the energy stored. It shows the energy stored in electric field. It is the energy stored in electric field. The third term shows that it is the energy stored in magnetic field. First term on the left hand side shows the power flowing out of the surface. So the total power flowing out of the surface will be the sum of ohmic loss, energy stored in electric field, and energy stored in magnetic field. That is the concept of Poyntings theorem. Integral over S E cross H ds, or power flowing out of the surface. Integral over V sigma E square dV shows the ohmic loss. Half into integral over V dou by dou T of epsilon E square dV shows the energy stored in electric field. And the last one, half into integral over V dou by dou T of mu H square dV shows the energy stored in magnetic field. Okay, so the concept is the power flowing out of the surface is the sum of ohmic loss plus energy stored in electric field plus energy stored in magnetic field.